Hi everyone, welcome to OpenShift Insider. So today we are in the second episode of this podcast series. So with me, as usual, I have Randula and Sandarenu joining me. So if you can remember, last episode we discussed about why application modernization is important. So with these two experts, we discussed about it and they gave some real good insights into this area. So today we are actually going to continue from where we left. And so basically we are going to discuss today what are the tools to convert your modern applications and what is the approach. So this is the area that we are going to discuss. So I'm going to turn to Randula to basically get to know about this. So Randula, can you just explain us what are the tools to convert your modern applications and what is the approach that we need to take?
Right. Okay. So Krishal, as you mentioned last episode, we have discussed about the why important the modernization. There's a lot of modernization keyword buzzword is going on. People are trying to understand. So now very important thing is now you know why you need to convert your application, modernize your application. And now this episode we're going to talk about the tools. So when it comes to tools, I want to break it down for three areas.
Okay.
Right? First area is the containerization part of it, which we modernize, which is the key part of modernization. So, and the second part is orchestration. So you containerize the application, then you need to run the application on that.
Okay.
Then the third is there should be a process to do it, right? So we're going to go out of the manual process and do that. So first part, when it comes to containerization, the top two tools, the technologies in the market is Docker and then Podman, which is coming up very kind of popular, very fast with Red Hat. So those are the two tools for the containerization side. Then orchestration, we have open source platform, which is Kubernetes, which is very popular. And then for enterprise grade, support grade, that comes with Red Hat OpenShift to manage scale containers on that, orchestrate basically. Then the third is you do all these things, but there should be a process for it, right? So we call it DevOps. You might heard about the DevOps process. So there are popular tools like Jenkins. Other one is GitLab, CI/CD side of it. So a lot of more complex as well as more popular tool is the JIT, which has more features to run it. So those are the three factors when it comes to containerization you need to know on a very high level, so you can start exploring on that.
Okay, interesting. So I think to further understand this area, I want to turn to Sandarenu. So Sandarenu, according to what Randul explained, what I want to know is what are the techniques behind it, and how do we converge our traditional applications?
Yeah, so I think last time also we discussed briefly how we can get started on that one. So main thing what we have to do is we have to first start small, baby steps kind of thing, and then build on top of that. So there are techniques like repurchase, refactor, things like that. But in our case, what we use is the refactor, because since our product is in-house build, we can't repurchase things, so we have to refactor, and we can't retire and rewrite also, because the effort for that is very high. Even though people would like to rewrite, developers would love to rewrite, but it takes a lot of effort. So the approach we chose was to refactor. So in that approach, now since we are going for a containerization and then for Kubernetes based deployment, so there are few key things that we have to do first. Mainly the things like the log management, monitoring, and if the application is having any shared state kind of thing, so we have to identify those things first, and we have to come up with a plan how to implement this in this new Dockerized and the Kuberneterized deployment. Because in the traditional approach, the application logs and all that, even though the application crashes, logs remain in the server. Okay. But when we deploy it in a Kubernetes kind of environment, when the pod crashes, logs will not be available, so that entire machine is kind of gone kind of thing. So we have to have a additional layers on top of it to get these logs retained and stored in a different servers, and how do we manage these alerts, monitoring and other things. Like previously we were using these script based monitoring and things like that, so we can't use those things. So that identifying the areas and and then identifying the tools to be used and the techniques to be used, that, and after that going for the modernization. So that's the approach we use. So we started with a small application, non-critical, and tried out that one and perfect our technologies and the practices, and then we move for one module by module to entire platform. So that's how we went on.
Okay, it's very interesting. Okay, now like with the discussion, like I kind of have another question to Randula. It's like now most of us hear Docker and Kubernetes, and it's like a popular buzzword in the world, in the market, right? So the thing I want to ask is like, what is the real difference here?
Right. Okay. So yeah, Docker, because when you start the Kubernetes, what you call containerization, the baby steps, what we say is the Dockerization. We call even Dockerization and then the containerization on it. So Docker and Kubernetes plays two different roles. We should not mix it, because with Docker you can still containerize and run the containers as well. So there's the mix-up comes up on that. So I will segregate it for 3 or 4 areas to kind of make it clarity. First thing is the role. But we need to understand the role of Docker and role of Kubernetes. So role of Docker is basically to containerize the application. From your traditional normal application, you can make it a container. So that's we use Docker for it. But when it comes to what you call Kubernetes, that's basically where you will deploy the application, or Kubernetes is the part that orchestrates the containers application. To further elaborate, let's go to the next step on the scalability part, running. So Docker, you can run the containers and applications on Docker basically. But when it comes to scale, let's say 50, 60 containers on the enterprise level comes in, there should be a proper orchestration happen. There should be a scalability, right? There should be observability comes in. So those things to be properly managed, that's where the Kubernetes comes in. Then the third aspect is when you run the containers and all, you can't manually do a lot of things, because there's a lot of containers are coming in the market. A lot of containers on the enterprise level can go for applications, database, to different web applications, part of it. So if container goes down, you have to monitor and again start the container, right? So there's a lot of manual work you have to do with Docker. But when it comes to Kubernetes, there is a self-healing mechanism where if the container goes off or crashes, it will automatically start the container, right? And the other part is the load balancing part has been impressively done on Kubernetes, which is one of the best open source kind of a platform there to run container applications. So load balancing to self-healing, scalability and all, Kubernetes is kind of the open source platform that you can run containers in large scale. Okay, right. But when it comes to Docker, it's just for the developer purposes. You can do 1 or 2 containers and run your containers on the development environment to try it out. But to properly run containers on a large scale manner, Kubernetes is the part that has open source. So those are 2 roles where you have to differentiate, where you have to start and use.
Right, Randul, I think it was very clear. We can. You basically explained us what is the difference. So I think I want to turn to Sandarenu again, because I think you are the best person to answer this with your expertise and your hands-on experience. What I want to know is when we do these deployments in your tenure, in your work experience, what are your experience on these deployments?
Yeah, so we have this multiple Kubernetes deployment. So it's not easy. So there are kind of challenges when we setting up in Kubernetes in a production environment. So we have to set up the controller nodes, worker nodes, and then we have to configure them properly, and then to work Kubernetes in a proper way, there are a lot of other additional tools that we need to configure with Kubernetes, like let's say storage platform. So to get the storage for these device, these pods, so we have to select a storage platform and configure that, and then we have to install it and configure. So that is not an easy thing. And then so we have to set up something called service mesh to make sure that these interpod communications happen properly, and then we can do these load balancings properly, and this to make this internal communication through HTTPS too, because like now even the internal communication is need to be on HTTPS for security concerns. So we have to set up the service mesh and configure that one. And then the log management, as I mentioned earlier, so log management is a crucial thing. So we need to set up a tool to collect these logs, store them and visualize them, correlate them to get this log traceability and all that. So we have to configure those tools, and then this monitoring, alerting and all that. So there are a lot of, so each of these areas have different tools, like there are a lot of open source tools and commercial tools. So we have to select the tool, do a research and understand it, and then configure it and troubleshoot the issues, and to get those things everything working together. So it's a bit of a challenge, but then like only after that we can set up our application so that setting up infrastructure is a bit of a challenge. So yes.
Okay, so like from what you said, like, what I understood is like, we have challenges in Kubernetes, right? So I want to turn to Randula. So Randula, if we have, so since we have these challenges in Kubernetes, so what is the best platform for us to run containers?
All right. So thank you, Sadhran, also highlighted on the side of the Kubernetes. So Docker is a part just to try out the development side of it. Then we have the Kubernetes. Now we know we have the hands-on experience. Kubernetes has a challenge. So Kubernetes, when it comes, these challenges persist because there's a lot of open source platforms are running on top of it. The other part I want to highlight is the support. Because it's more community support. When you run the mission critical platform, the support is very important, right? Then the security. The security incidents happen these few days before. So when it comes to these areas, it's very important to have a very supported, secure, tested platform.
Okay.
And that's where the Red Hat OpenShift comes in. Right?
Okay.
So Red Hat OpenShift runs on top of Kubernetes with all these additional features part of it, right? And make it a one platform to run. So example, when, as Sandra mentioned, when you set up Kubernetes, you have to set up around 50 plus of third-party applications, third-party components together. Installation is so hard for it. But comparing to OpenShift, the installation is given and inbuilt. So it has installer, you can quickly install it. So all of these 50 plus platforms has one component with OpenShift, where you need to fix and install OpenShift only. That's one. Second part is the security. SC Linux and all security is inbuilt with OpenShift. So you don't have to worry, because when you do the Kubernetes, then you have to worry about security, what are the tools, what are the protocols and all stuff you have to use. So security perspective, it's full secured when you run OpenShift because it's inbuilt. The third part is the developer toolset and all, right? So when it comes to OpenShift, developer toolset is given. CI/CD pipeline all comes into play. When it comes to a mission critical enterprise environment and workloads, it's very important to focus on one platform, because then you run around the application issues. So when you have the open source, so open source is good to try it out and plan it. But when it comes to OpenShift, the support, security, and the platform upgrades are all inbuilt. So one of the best platforms, I would say, on the Kubernetes side, is the best platform is the OpenShift, because you don't need to focus about the platform, you focus the innovation. So platform itself, Red Hat has brought OpenShift on an innovative way. Now it's coming with OpenShift AI, and there's a lot of components are inbuilt, product self it's coming. So you don't have to worry about security support and all, it's inbuilt. So it'll be the OpenShift platform.
Okay, interesting. So I think we kind of discussed bit of an interesting area compared to the last episode, so we can really dig deep into this area. So today actually we are going to end the episode 2 from here, and in the episode 3 we are going to discuss what are the key differentiators of OpenShift, and also we are going to discuss some of the use cases also, right? So stay tuned for the third episode, and we will see you again. Thank you for joining today.
Thank you.
Thank you.